Hi everyone. Today our topic is Tyndall effect, very important topic from the science and technology part of your syllabus. So you look at this image, what you have seen. This is the light source. You can say consider it as a torch. Of course, you know about torch, right? This is solution, but it is clear solution, right? No other particles are mixed. So you can see that not visible. Light beam is not visible here, but this is colloid. Okay, milk. It's visible. Light beam is visible, but this is suspension. You can more clearly look at you can see the light source here, visible, right? And this suspension is made out of flour and water. So what you have seen, this whole phenomena means of this light beam visible or not visible is known as the Tyndall effect. So the Tyndall effect is the scattering of light by particles in a colloid or suspension. This one is colloid or this one is suspension. Okay. Now under the Tyndall effect, the longer wavelengths are transmitted more, while the shorter wavelengths are more diffusely reflected via scattering. So what you have got, that longer wavelength. See, this may be asked in the MCQ portion, right, as a statement. So in the Tyndall effect, longer wavelengths are transmitted more, but shorter wavelengths are more diffusely reflected back by via scattering. Now, the Tyndall effect is seen when light scattering particulate matter is dispersed and in an otherwise light transmitting medium, where the diameter of an individual particle is in the range of roughly 40 to 900 nanometer, that is somewhat below or near the wavelength of visible light, that is 400 to 750 nm. So you have seen that this Tyndall effect is directly associated with this type of solution where light scattering particulate matter is dispersed in a light transmitting medium. Light transmitting medium means like kind of water. See, lights are transmitted. But if the this type of particulate matter is being means dispersed in such medium, then we can see the light effect. More clearly, you can see here in this image also. You can clearly see the light beams, right? So again, we can say that this Tyndall effect, scattering of a beam of light by a medium containing small suspended particle. That suspended particles may be smoke or dust in a room. You know, in a dust, if a room, you often after suppose 1 week, right? Means that the room is closed for 1 week and you open the door and you will see that the dust is filled in the room and the lights coming from the window is clearly visible. So that is also an example of Tyndall effect, like the one in you can see in this image. So I'm repeating again, Tyndall effect, scattering of a beam of light by a medium containing small suspended particle like dust, smoke in a room that makes visible a light beam entering a window. Now, as in Rayleigh scattering, I hope you heard about this Rayleigh scattering, where short wavelength blue light is scattered more strongly than long wavelength red light. However, Rayleigh scattering occurs from particles much smaller than the wavelength of light, while the Tyndall effect occurs from particles roughly the same size as the wavelength of light. This may again be a part of your MCQ, remember. The effect is named for the 19th century British physicist John Tyndall, who first studied it extensively. So that's why this effect is known as Tyndall effect, because it was first studied by John Tyndall. Who is John Tyndall? A British physicist of 19th century. So this is all about Tyndall effect, a very important topic from your science and technology syllabus. Thank you.